Hi, you're listening to Chip Chat, a podcast from Intel where we talk about technology. You'll hear from experts both inside the company as well as those who work with Intel to create great things. I'm Marcus Yam, technology evangelist, and this is the first episode of the new Chip Chat. I had a conversation with Dan Ragland, principal engineer in Intel's performance tuning and overclocking architecture team. He's been at Intel for over 23 years, always on the PC hardware side of things, and he's among the most knowledgeable people on the planet on overclocking. If you're new to overclocking, you'll definitely want to pay attention. And if you're an experienced overclocker, Dan shares a little on what to expect with 11th gen desktop CPUs, codenamed Rocket Lake. I have a very special guest joining me today for our relaunch episode. He's smart, he's personable, he walks the tech talk, and he's certainly the most knowledgeable person I know on overclocking. Dan Ragland, thanks for coming on the new Chip Chat.
Hey, Marcus, great to be here with you today.
Hey, Dan. So quickly, who are you? What do you do?
Yeah, I work on Intel's overclocking team. There's about a half dozen of us or so that are working to develop overclocking features, knobs for tuning, and deliver that overclocking experience. And our little overclocking team actually works with engineers across Intel, whether they're CPU teams in Israel or India or Malaysia, all around the world. We're working with them to integrate the overclocking capabilities.
Oh, wow. It's a pretty developed and big team. Okay. So obviously you're one of the experts in overclocking, big team, but let's back up. For those who don't know, what is overclocking?
Sure. At the high level, overclocking is extracting more performance out of your processor or your platform. So what that means is typically you're trying to get the frequency of your processor to run a bit higher than it would normally out of the box. So for example, you would raise your CPU frequency by, let's say, 200 megahertz. You would adjust the voltage to go along with that. You would tune your power limits, a number of other parameters to essentially extract more processor frequency. Likewise, you could be overclocking memory, and memory has similar methodologies. But for example, you could buy extreme memory profile technology. This is overclocking memory. Plug it in your system, and you're running at a higher memory frequency than you would have out of the box by spec.
So this means when someone's shopping for, like a desktop CPU and they see a certain number of gigahertz and megahertz, there's hidden potential in there. There's more they can get out of that.
Potentially, yes. So when we provide a processor product, we have a number of different SKUs. And let's say a SKU is like a model number. So 9900K was a classic one. So that's one SKU, and you might have 3 or 4 others. Well, when we test in the factory these processors, we put them in different buckets according to their capability. But when you bucketize, say, a processor like that 9900K of the past, it might have more capability than its buckets. There was no higher bucket. So what you can do as an overclocker is you can try it and push the frequency a bit higher and see what you get. Typically, you'll find that there's a good percentage of units that can operate at higher frequency than spec.
Okay, so it sounds a little bit kind of like, hot rodding your car. Is it safe?
Yeah, I love your analogy of the hot rod. It's a lot like that. So some people may be a little bit more risk averse. So what happens is when you're overclocking, you're running typically at higher temperatures and higher voltages. And temperature and voltage are the two parameters that affect the long-term life of a piece of silicon. And so by running at that higher voltage, you can affect the life of your processor. Now, smart overclockers will carefully balance the amount of time they spend at an elevated voltage state, and then they'll also use extreme cooling or better cooling, like liquid cooling, to manage the temperatures, and that enables them to get more life out of that overclocked part.
Cool. Okay. So this sounds like something that is, I guess, relatively safe, especially if done within the controlled parameters. Why don't processors come overclocked from the factory? Though I will say that I've seen some, on graphics cards, they say there's a factory overclock to them, or I think PC builders also build in some overclocking there. Why doesn't Intel provide that right from the factory?
Yeah, good question. So we want to be sure that the products that we sell are rock solid and stable out of the box. And if we overclock them, we open ourselves up to the potential where we wouldn't be able to maintain that perfect brand stability and quality. So we prefer to allow overclockers to utilize their own kind of decision making, understand the risks, provide their own mitigations. So yeah, I don't think we're going to find a factory overclocked processor coming out anytime soon.
And I guess when there are so many numerous tons of shipments of processors out there, I think that getting that uniform amount probably just comes down to what it says in the box. Um, but on top of that, I've heard the term that overclockers, they want to find the golden sample, um, or cherry pick that. Can you kind of explain a little bit of the background of what is the golden sample?
A lot of folks think of a golden sample as that unit that might represent the most headroom. Um, and yeah, people are always looking for that golden sample, and there's all different thoughts about where that comes from. Is it this particular factory, or is it this particular date lot, or that sort of thing? Um, a lot of that, there's some truth to it, but in general, it's not quite that simple. It really does come down to testing that unit or units you have in front of you to see what kind of headroom they have.
Yeah, when you talked about this, the specification of like which factory, which date, kind of brings back one of my earliest memories on overclocking. And I'm by no means a super enthusiast overclocker, but overclocking is really what got me into PC building. And I remember I was able to go into it was a small mom and pop PC shop back in the day when those existed, and I asked very nicely, and they let me go in the back and look at the tray of processors to find and I was looking on forums on which one had the right date, the right serial number, the right code. And of course, it wasn't a golden sample. I couldn't test it myself, but I kind of gave myself the best odds of it. And oh man, I'm sure overclocking has come a long way since then. You mentioned liquid cooling, but I do remember taking the first processor I ever overclocked was the Intel Celeron 300A. And I remember putting some Teflon tape over some of the pins and putting in the motherboard so it ran at 100 megahertz frontside bus instead of the 66 megahertz, going from 300 megahertz to 450 megahertz, and that was probably still my favorite overclock to date.
Yeah, that 300A Celeron was one of the most popular overclocking parts. It had incredible headroom back then, so people talk about it to this day, right? That was sure fun to kind of get that kind of headroom out of that very reasonably priced part.
And so that's my history with overclocking, but I'm sure there's a lot more to it. Can you share a little bit about what's Intel's history with overclocking?
Sure. First, I want to explain. So sometimes people wonder, why is there a period in the history of PCs where overclocking was kind of less in vogue? And I wanted to share a little bit of that, and that might inform kind of the past and then where we're heading. Long ago, processors had a ceramic top, and on that ceramic top, they would mark the frequency of the processor. And back then, you configured the ratio or the frequency based on jumpers on the motherboard. Well, what happened was there was some what's called basically deceptive remarking going on, where they would rub out that frequency of the processor and replace it with a higher frequency and then sell it. So that caused the PC industry to say, hey, wait a minute, we've got to be really careful about this. We don't want people selling a 33 megahertz processor as a 66 megahertz processor. Well, around the Pentium 2 days, to prevent that, the ratio became locked. And so that was around 2000-ish, 99, 2000. And so from that point on, overclocking kind of had to reemerge. And so you saw that happen. There was a group within Intel that was very focused on the customers, these enthusiasts and overclockers that really wanted overclocking back. And so we came up with a means that was satisfactory to maintain safety and reliability of the processor, so you knew what frequency of a processor you were buying and that it was legitimate. And we mitigated that and came out with what's called the Extreme Edition processor, and that reintroduced overclocking. And then from there, we had the K SKU come out, where it allowed overclocking, but at a broader range of price points and SKUs. So that was a little bit of the history of overclocking. And from then on, the K SKU, we've just gone up, and up in terms of more features, more overclocking capabilities.
Now, when you say K SKU, you mean these processors that have the K at the end of them, like the 9900K, 10900K, and I know soon we can talk about the 11900K. That's what you mean by K, right?
Yeah, that's a good point. Yeah, that the K suffix indicates that it's overclockable.
Now those are overclockable. So what makes the K SKUs actually more overclockable than the ones that don't have the K?
You'll find that the K SKUs tend to be at the top bin of their particular category, or using the term bucket I used before. So when you're buying, for example, the 10900K today or soon 11900K, that's the top of the stack. And so units that are in that top bucket will tend to have more, on average, more overclocking capability than, say, something at the bottom of the stack, like an i5.
So, going a little bit back, now we've got the K SKU. With so many years of overclocking with Intel, what have been some of the innovations along the way that have been specific for overclocking?
Yeah. Oh, this is an exciting topic, and you're going to have to stop me here if I go on about this too much. Yeah. So, in order to achieve the top frequency, we've learned that not only do we need to offer the B clock control, the base clock frequency control, and the ratio control and voltage that we've had for many years, but as, for example, new instructions came out like AVX2 and soon to be AVX 512 that we've disclosed, those instructions are more power hungry and require higher voltage. Yet many of the overclocking software applications or games aren't necessarily using those instructions, or at least they don't need to run them as at a high frequency. So we came out with a knob called the Avx Offset Knob that allowed you to separate your frequency when AVX is running. Essentially, bottom line of this is that allowed about 200 megahertz of additional overclocking headroom. So the AVX offset is one. Another feature we have is called per core HT enable disable. So you can actually turn on and off the hyperthreading for each core on your processor. And again, for certain workloads, like maybe you only need 8 threads, so you could turn all HT off. Or maybe you need 12 threads, you can turn some of your HT threads off. By doing that, when you turn off HT, you can actually get higher frequencies on your remaining active cores. That's another fun feature. There's many more examples I could go into, but I don't know how you're doing on time here.
No, this detail is great. And I think that, for the people who are definitely enthusiast overclockers, they love all these different knobs and controls and how to tweak and tune. Um, but that sounds a little intimidating for some people. Are there any tools out there to really help people just, I don't know, click a button and have it overclock? Can it even be that simple?
That's a great point. We don't want to intimidate folks with all these overclocking knobs. So we actually have provided 2 different software applications to make overclocking more simple. So the first one is called Intel Performance Maximizer. This is basically your one-click overclocking solution. So you install it, you run it, and it configures everything to maximize the performance of your overclocking. So that's great for somebody who's just getting into this, doesn't want to have to know about all these knobs and all this kind of geeky stuff that I'm talking about right now. That's for you. But I think you'll find out, just like hot rodding cars, people who like to tune their cars, you're going to like it. And then you're going to want to move up to an application we have called the Extreme Tuning Utility. The Extreme Tuning Utility is like a digital dashboard with all your overclocking knobs. Sometimes I call it the face of overclocking, because as a user, you might not need to know all these details I was just talking about. You just look at your dashboard and say, all right, I'm going to move this frequency up, I'm going to change this voltage, I'm going to adjust this power limit, and then I want to monitor the temperatures, how hot is that engine running at, and so you can manage your cooling, basically all that kind of stuff you can control under the Intel Extreme Tuning Utility. So that's more for the intermediate overclocker.
So, using these utilities, do they get, like you said, stepping up from the one click to the controlling all the different knobs? Is that the same as when people had to control overclocking using dip switches and BIOS settings? Is that the same thing, or is this something else?
Well, it covers all of that history. Back when, yeah, we had those jumpers you would move for your ratio, or a dip switch. Dip switch was the modern version of jumpers, and so on. That's basically now all controlled right there under the Intel Extreme Tuning Utility. Something, I'll just make an estimate, between 85-90% of overclocking knobs are all available right there in real time in Windows, right through the XTU interface.
Cool. Okay, so Intel's going to be releasing the new Rocket Lake desktop processor. That's the 11th gen core Intel processor. It's coming this quarter. There's a new architecture featuring the Ice Lake core architecture and the Tiger Lake graphics architectures, and actually has a 19% IPC improvement. So I think this is going to be a pretty good one for gamers. And on the same topic, there's got to be some new overclocking technology in there, right, Dan?
That's right. There's a number of new overclocking features. Some of them we're going to save for a surprise, but some of them I could actually talk about today. And the one I really wanted to highlight is we are going to make a very large expansion in the area of memory overclocking. And there's a couple things I'll point out. Number one, the average overclock frequency from memory will increase over the past. So you'll see much higher frequencies. I'm not going to promise the frequency today, but let's just say it's better than 10900K. The 11900K will also have additional memory overclocking capabilities. So we're bringing something on called Gear 2, which will allow for even greater memory overclocking capabilities. But the second major area I wanted to highlight around memory overclocking is we're going to expand and support memory overclocking on SKUs beyond K SKU and beyond just pairing with the ZPCH. So you'll see overclocking of memory available all the way down into some of the value price points, which should be interesting to help introduce new overclockers who may be looking for a little bit more memory overclocking capability, a little more memory performance to help their games. They will be able to experience that here on the 11th gen product.
Cool. So walk back with me for a second. So there's frequency overclocking with the CPU. What's the overclocking on the memory? How's that different? How does it interact with, I guess, the ratio overclocking on the processor?
Yeah, so memory overclocking is helpful when you're trying to feed the cores with data faster. So certain workloads, including mini games, there's actually been a number of articles on this. The games can actually benefit by being fed that data faster. And so you could do that by raising your memory frequency above the supported frequency into the overclocking range. And that can actually improve performance in certain workloads, including games.
So sticking with Rocket Lake has this new architecture, and in my mind, I'm thinking that we've had years of refining that 14 nanometer process and having essentially a very standardized architecture with an increasing number of cores. Basically, my question is, what is the engineering role of your overclocking team? Because I have to imagine that designing a new chip takes years. Um, how is overclocking's role in that design of that chip from the design tool all the way into the customer receiving it in a box?
Yeah, great question. And this is where a lot of the fun happens. So the overclocking team gets involved very early. Something like 5 years before the product reaches market, the overclocking team will be working with the experts at Intel's development team, so our processor architects, and will provide some of the features that we're looking for to extract more performance out of the great architecture these brilliant engineers are already developing. So our goal is to take something great and make it even greater. So an example of the kind of thing we might be doing in that time frame would be introducing new tuning knobs to adapt to new architectures. For example, there might be a new feature that comes out, and we need to be able to make it overclock well. We also bring forward our what we call legacy overclocking features, or those features of the past, and they actually have to be adapted to work with new architectures. It's not just an automatic thing. So we'll start working on that architecture phase, and then we'll get into kind of the pre-execution phase where we'll start planning out, hey, now what kind of motherboard are we going to need? What kind of power delivery do we need to do our overclocking? And then the fun really gets into high gear when the processor reaches the lab, those very early samples. And we start working with teams across Intel to validate the overclocking capabilities, to understand how does this behave under liquid nitrogen? How does this work at various temperature and power points? Does this affect the cooling solution needs of the future? So we start working on that very early on. That kind of culminates with validating all the overclocking features, making sure they're all up and running. And then I guess the big one, the one we really enjoy, is we'll hold like a workshop, an overclocking workshop with our key customers, especially the motherboard customers, and we'll help them tune their board. They have some advice to provide as well on things we could do differently. And so we'll basically tune and optimize that product and then get ready for our launch. It's a long process.
So it sounds like a lot of engineering goes behind it. Now, one thing I wanted to step back and ask is, I've seen these really cool photos and videos of professional overclockers pouring liquid nitrogen on a processor. That's not everyone needs to use that, right? There's regular person. I see the liquid nitrogen as the extreme sports of overclocking. But what is the minimal level of entry that someone needs to get to overclock a CPU?
Yeah, I mean, really, you if you purchase a motherboard that's designed for overclocking, a processor that's a K SKU, um, you're really ready to overclock. What I would also do is pair that with a great cooling solution. So, liquid cooling solutions now you can get for $100 or less. So it's super attainable. You build a system with those ingredients, and you're ready to start doing your basic tuning. Whether you use our Intel Performance Maximizer or our Extreme Tuning utility, you can get that overclocking up and running very fast. And you're right, the liquid nitrogen overclocking kind of gets a lot of the attention, and it's really a sport thing. So we do enjoy that, but the majority of overclockers don't quite enter that space. They're usually using a off-the-shelf liquid cooler with our KSQ processor.
So Dan, clearly you're the expert at Intel. How did you get into computers, and how did you get into overclocking?
Yeah, oh boy, this is a fun question. My first job in high school was working for what we used to call a mom and pop computer shop, a small store that built what we called clones back then, basically assembled the motherboard, the chassis, all the components. And back then, as I kind of mentioned before, uh, everyone kind of had the opportunity or was enticed into overclocking because when you would build that motherboard, you'd put the processor in, and then you would look at your manual and say, all right, I need to set these jumpers for 33 megahertz. I know that sounds low. Or these jumpers for 66 megahertz. You can't help but try 66 megahertz when you had a 33 megahertz processor there, right? So I kind of grew up doing that, right? And hey, what would happen if I did that? And that got me interested in overclocking. So I found that there was a pretty high success rate if I could cool it, and I would change the voltage a little bit on those. At that time we're talking about Pentium days. I could get a little more performance, so that got me kind of into it and gave me a taste of overclocking.
So how did that lead you to doing overclocking at Intel?
Yeah, so at Intel, I started working on our high performance motherboards. I started back in 1998, working on the motherboard team, and I really got to meet some of our customers that were into that enthusiast, what we called boutique kind of experience, where they would tune a system and provide it to, essentially what we now call enthusiasts. Back then, they were a lot of celebrities, or they were NASCAR drivers or sports celebrities. They wanted to have whatever was on the market. They wanted the best, and then they wanted to make the best better. And I really got to learn from a few customers what that was like and what they needed. And that, again, gave me another flavor, and it gave me excitement around the idea of overclocking and making our best even better. And so we started, for the first time, supporting overclocking on Intel motherboards to cater to those customers. And then from there, every year we want to do something better, right? All right, we now have an overclockable motherboard, but what if we made a better power delivery solution? Or what if we invent a new cooling solution? Or what if we make liquid cooling more affordable for the common person? And just each year, we tried to up the game and find ways to make overclocking either a better experience or more attainable. And it's really, really been that recipe over the years that we've used to evolve our overclocking capabilities.
Oh, that's great. I didn't know that your team actually extended its innovations to making liquid cooling more affordable. That's pretty cool. And I've noticed that too. That liquid cooling used to be um, something unattainable. Right now, you can just buy one right off the shelf.
Yeah, that's right. And I should say we work with engineers all over Intel. So the overclocking team, we get some of the prestige or attention around it. But the truth is, there are engineers throughout Intel that are interested in overclocking and making our best better. So I get to work with like PhDs. These guys are teaching college courses on thermomechanical, and partner with them and say, hey, we have this need. What do you think about this? And of course, they get excited. They love the challenge, right? How can I make a better cooling solution than the industry has? Or how can I make a pre-charged liquid cooling solution that just makes it so you can buy it over the counter versus having to, cut hoses and pour water into radiators and do all this. So yeah, it's been great to work with different people across Intel that have contributed to the success of overclocking over the years.
Wow, that sounds like a dream job for an overclocker. Is there room on your team to grow?
Yeah, we're looking for good people all the time. Um, you know, and it's awesome. We're inside Intel, so we've got our choice of some of the best engineers, and then in external hiring, we're growing around the world. Um, we're looking for engineers in Costa Rica right now. So yeah, if you're an overclocker with an engineering background, we'd love to talk to you.
Oh, very cool. So, okay, so you eat, live, breathe overclocking at work. Do you still overclock at home? What's your personal setup?
I do, and I got to tell you, my I really got a taste for overclocking when I was a gamer, uh, and I still game, but I was serious into the gaming in my 30s, and I was not good, and I couldn't. Okay, there's skill, and then there's equipment. Skill you got to work on. Equipment you can solve, and so I learned about. I just started off. I overclocked my processor, my memory, and upgraded my graphics card, and I went from being at the bottom of the pack to a solid, first quartile, top 25%, just with that overclocking and better hardware applied. So lesson one, then I'd go off and learn to be a better gamer. This will date me, but I played the whole Quake series. So Quake 3 and 4 were my big ones. I played more hours than I'll ever admit on that. So that got me into it. Now today, having grown up, so to speak, and with a wife and child, I'll tell you one of my killer applications for overclocking today is my daughter. We've purchased her a number of DVDs, but swapping DVDs on a car trip is not easy. So we wanted to put them on her tablet, and so what I found is that job of converting a DVD to a file that's on the tablet scales linearly with frequency. In other words, if I overclocked by 25%, I could get the job done 25% faster in converting those DVDs to tablet format. And so, when I used to, it used to take, say, an hour for 4 discs, I can now do, 5 or more in that same time frame.
Wow, that's I can't think of a better story than you said. You started to up your game to get more frames per second so you can see the other guy before he sees you. And now you're just transcoding DVDs faster thanks to overclocking. Well, Dan, this has been a real pleasure. Thanks so much for talking to me about overclocking. I've learned a lot. I'm actually really excited for all the new overclocking innovations we have ahead for Rocket Lake. So I can't wait for that. And I was going to say, stay tuned for that. But thank you for being our first guest on the new Chip Chat podcast. Hope you have a good one. Let's talk again soon.
Thank you for the opportunity. This was great.
That was my conversation with Dan Ragland, principal engineer in Intel's performance tuning and overclocking architecture team. You heard today how approachable overclocking can be with the K line of processors, along with software like the Intel XTU Extreme Tuning Utility and the IPM, that's the Intel Performance Maximizer that lets you overclock easily with just a few clicks. Dan also gave us news that the 11th gen Rocket Lake desktop platform will have expanded memory overclocking, along with other new overclocking features that will be shared at launch. This is the first of the new Chip Chat, and in the coming weeks, we'll hear from other experts. We're available on SoundCloud and other podcast platforms, as well as on the Intel Technology YouTube channel for a video version. Thanks for tuning in to Chip Chat, and I'll see you in the next one.